Alright guys, welcome back to Underground Science, and in this video we'll be talking about the noble gas notation, right? In the previous video I talked about just regular electron configurations, how to write it, and in this video we'll talk about noble gas notation, which is pretty much a shortcut, right? Noble gas notations, and then we'll see some examples that I've circled in the periodic table, just random examples of drawing the orbitals for the electron configurations. Right, so actually drawing like the 1s and 2s and drawing the magnetics, or not the magnetic, the spin quantum number of plus 1/2 and minus 1/2, and so on. All right, so let's go ahead and get started. So let's start with magnesium first. Okay, so that's our first example. And if you guys have already watched my video on writing electron configurations, this should be like a piece of cake, hopefully, right? So let's go and write down the noble gas notation, all right, for magnesium as electron configuration notation. So noble gas notation, we have to look at our noble gases, which are right here, this 18th group of the periodic table. Okay, and so instead of writing for magnesium, the electron configuration as this: 1s2, 2s2, 2p6, and 3s2. Right? This whole thing right here, all of this, we can replace by just simply writing in brackets the noble gas that came before the element you're trying to write the electron configuration for. So what element are we trying to write the electron configuration for? Magnesium, right? So what noble gas comes before magnesium? We'll just look back, right? So we're at magnesium, go back one to sodium, then go back another one, which comes back all the way here, neon. That's our most recent previous noble gas, right? If you say it like that. So all you have to do is just replace all that with neon and then just keep the 3s2. All right, that's it. We're done with the noble gas notation for magnesium. All right, so you can write it either like, so this is the correct answer, or this is also the correct answer. Oops, I drew over the 2. All right, well, I don't really have that much space, but this is also the correct answer. So both of these are correct, okay, because both of these represent the same element, but just in different notation. This is called the noble gas notation. All right, so this is noble gas notation, and the top one is just the regular electron configuration notation, the long way, pretty much. Okay, so let's practice that with iron next. Okay, so iron. Oops, iron, there you go. So again, let's write the regular way, right, which is the long way. So 1s2, right, our first principal quantum number, s orbital, 2 electrons can fit in our s subshell. And then we have to write our 2s2, then 2p6, right, 6 electrons can fit in our sp, 3 different orientations for our p subshell, right? Remember from the quantum number videos, we figured that out with finding out the magnetic quantum number. And then we have our 3s2, then our 3p6, 4s2, and remember we have to be careful, we're still in our third energy level when it comes to the d subshell or d orbital or transition metals. So this is going to be 3d6. All right, now this 3d6 right here, this till here all the way to 3d6, right, this whole thing is our regular notation. It's correct, it's still the correct way, but it's the long way, right? To save time, if you're like running out of time on a test or something, just use the noble gas notation, right? If the direction says you can, right? But if it says no, say do the long way, then I guess you got to do the long way. But so the noble gas notation, all you have to do is start here, then work your way back and look where the most recent previous noble gas is, which is right here, argon. All right. So argon is our most previous and recent noble gas from iron. So what you're going to do is you're going to replace all of this. All right, you're going to replace all of this until argon. So in noble gas, whatever you place should be that electron configuration for that noble gas. I don't know if that made any sense, but okay, so watch this. We're going to replace, I'll explain why, but we replace all of this. All right, now you're probably wondering why not 4s2, because, one sec, all right. So argon, and then we're going to write 4s2, 3d6. So why didn't we replace 4s2? because when we write 4s2, we're not talking about argon anymore, right? We only have to replace the electron configuration values that we wrote only till argon. And if argon's electron configuration, if you write it, is this 1s2, 2s2, 2p6, 3s2, 3p6. That's argon's notation. So we can just replace whatever argon's notation was with argon and then leave the rest. All right, so that's how you shorten when you shorten your electron configuration notations. All right, last one, let's try iodine right here. All right, so let's try iodine. Let's choose blue, I guess, again. All right, iodine. So for iodine, again, let's write the long way. So let's go ahead and, you know what, since I just want to have the periodic table like while I see it, or write it while I see it. So let's write it right here. We'll have to change, or you know what, let's just make a new page. Screw it, yeah, there you go. All right, so iodine, right? We're on iodine, and let's write the long way, 1s2, again 2s2, then we're on the p orbital, right? 2p6, 6 electrons can fit, and then we're on 3s2, 3p6, 4s2, 3d10, because there's 10 electrons within our d subshell, our d orbital, and then we have 4p6, then we have 5s2, then we have 4d10, and finally we have, we're on our 5th energy level, so 5p, because we're on our p orbital, and 5. All right, because remember, just a refresher, this is our p orbital all the way here, right? And then notice so helium is not part of the p orbital because it's part of the s orbital. So let's go and draw the arrow down like that. All right, so the s orbital is right here. That's our s orbital. This is our p orbital. And then the whole transition metal phase, or the whole transition metal block, the d block, is our d orbital. All right, and these are part of our f orbitals right here. All right, so this is the long way, right, for iodine. But now let's go and write the noble gas notation way. So again, let's trace back and see what the most recent previous noble gas is until we reach iodine. Okay, so no noble gas here because we know it's group 18, so it's not here. Then we go back to the other previous principal quantum number of 4, at the energy level of 4, and there you go, krypton. All right, so krypton is our most previous recent noble gas from iodine. All right, so again, krypton's right there. Okay, so now let's go and figure out what krypton's electron configuration notation is, and then so we can replace that same electron configuration notation for krypton, and then we can replace that notation in for iodine. All right, so krypton's electron notification, I don't know why I said notification, electron configuration is, right, we have 1s2, again, we have to go through the whole periodic table, 2s2 to p orbital, our 3rd energy level s orbital, our 3rd energy level p orbital, right, 3p6, so we're at argon, and then 4s2, we're at calcium, and then 3d10, we're at zinc, and then we're at 4p6, and we're at krypton, right? So this is krypton. So see, watch this. All of this right here is krypton, okay? It's just matched. It's the same exact electron configuration notation. So why write all of that, right, for iodine? So that's the beauty of noble gas notation. Instead of writing all of that for iodine, replace that whole thing. We can replace the whole thing but just by saying krypton, right? We're saying, okay, here, we're putting in krypton's electron configuration notation, and then we just continue it from there. 5s2, 4d10, and 5p5, right? So that's iodine's noble gas notation. Okay, so it's noble gas notation is just to shorten. Okay, just to shorten the electron configuration notation. All right, noble gas notation. And that's it. So that's noble gas notation for iodine. And now, instead of drawing now from again, we're going to look at the same elements. Instead of drawing it now, we'll draw in the next video. We'll leave off right here, or we'll pick up from right here. It's just going to be another page with the periodic table, and we'll see we'll look at the drawing of it, like when we draw our electron configurations, right? When we draw like a positive spin quantum number, the negative spin quantum number, negative 1/2, positive 1/2, and then we're also going to look at the off-Bob principle and the Pauli exclusion rule, all right? So see you guys in the next video, and we'll pick up right here.